Hey guys, welcome back to a new Bluebook robotics video, and today we're stepping a little bit outside of our usual engineering and robotics projects to focus on something that matters just as much: strong math fundamentals. I'm going to be starting a new series today called the SAT Math Bluebook Walkthrough, where I'll upload walkthrough videos on how to solve every single problem on Bluebook. But the only difference is that instead of solving it by hand like most videos show you, I'll be doing it on Desmos and showing you how to do every problem on it and showing you all the different tips and tricks that I know. So in this video, we're going to walk through the math section of practice test number 5 from Bluebook itself for the SAT. I'll break down each problem, show you guys the Desmos approach, and explain the reasoning behind every step so you can fly through the math section when you get to the SAT, or when you get to the math section of the SAT on test day. So no matter your skill level, this walkthrough will help you understand how to do the math section faster and more efficiently to help you get the highest possible score. So without further ado, let's get started. Alright guys, so now we're going to start with our practice test. We're doing just module 2, 1 and 2 of the math section. The reading we might cover in a different video, but for today we're only going to be doing the math section. And we're starting with practice test number 5 on Bluebook. So I would recommend first that you watch this video, and then after you watch this video, you then try and do the Bluebook test and see if you can get an 800 on it without having to come back to the video. And if you have to come back to the video, that's totally okay. Just make sure you try and limit yourself as much as possible. Try and take in as much information you can from this video. Try the practice test yourself. See how well you do. And if you need to come back to this video for one of the questions, then you can do that as well. And hopefully you can get an 800 on this practice test. Alright, so let's start with the first question. A veterinarian recommends each day that a certain rabbit should eat 25 calories per pound, plus an additional 11 calories. So what's the equation that represents this? So at the beginning, we have 25 calories per pound, so we know it's going to be 25x, C is 25x, so anything other than that is going to be wrong. And we know that it has to eat an additional 11 calories, so our only answer choice that's left is D, because C doesn't include the 11 additional. Number 2, a special camera is used for underwater ocean research. The camera is at a depth of 39 fathoms. What is the camera's depth in feet? So this is just a simple conversion. This is 39 fathoms times 6 feet, which gets you 234 feet. Next, number 3. In the figure, line M is parallel to line N and line K intersects both lines. Which of the following statements is true? So in this case, if you've taken geometry before, which I'm sure you have, you'll know that which angles are equal to each other. So in this case, 145 here, it would also be equal to 145 here. So this angle right here would also equal 145, just like this angle would equal this angle. This angle would equal this angle because they're alternate interior. These are alternate exteriors that equal each other. And then same thing goes for the other side. So then if this angle is equal to this angle, that means this angle is also equal to this angle. So the value of x here would have to equal 145. And this is just a simple geometry question. Just make sure you touch up on your rules and which angles are similar to each other or congruent, which angles are the same, like alternate interior. You don't have to know the proofs, just know like a simple general which ones are equal to each other in lines like this. Number 4, the function represents the total cost in dollars of attending an arcade. When X games are played, how many games can be played for a total of $58? So we can type this equation to Desmos. F of X equals 14 plus 4X. And we're trying to find how many games can be played for $58. So 58 in this case is our F of X. So if we set Y equal to 58, which creates a new line, we can find out what the point of intersection is. And that's when X equals 11. So you can play a total of 11 games when for a total cost of $58. Number 5, if 4x minus 28 equals negative 24, what is the value of x minus 7? So we can plug this in to Desmos, and we can do a little cool trick called regression. So that's we do this keyboard, the ABC, and then you need this little squiggly line here. And this is going to have, this is going to set something equal. So it's pretty much going to solve for a constant. So instead of using an equal sign, you use this regression symbol, and it solves for a constant. So in this case, instead of using x, because x is actually a variable, Desmos recognizes a variable, we have to switch that over to t or b, or even something like x1 also works. And that essentially finds out that this variable, x, is equal to 1. So now we can do what is t minus 7, x minus 7, which is negative 6, and that's our answer. This is a cool little way to use regression, a very simple way. Number 6, the amount of Hannah's bill order, the amount for her order was $50. If she gave a tip of 20 amounts, what is the amount of the tip she gave in dollars? So what's 20% of 50? And that is $10. Next. 5 types of sea turtles each have a nest. The table shows an original data set of the number of eggs that each turtle laid in its nest. A sixth nest with 121 eggs is added to create a new data set, which of the following compares the two means of the data set. So Desmos actually has a mean function. So you can type in mean and type in a few different values. So 147, 144, 148, 136, 139, and that's the mean for our first data set. And then for the second data set, you have 121, 149, 144, 148, 136, and 139. And that gets us a mean that's less than the first one. So that means that the mean of the original data set is greater than the mean of the new data set, and that is true. Next question. The shaded region shown represents the solutions to which inequality? So in this case, we can just type in all our solutions and then see which matches up with the picture. This definitely does not match up. So we can do -1 minus 3x. This also doesn't match up. Plus 3x doesn't match up. And minus 3x, or sorry, changing the sign first. So this doesn't match up either. So now when we do the last one, we see, oh, look at that, that matches up perfectly. It has the intersection at roughly half, yeah, 0.3, touching the point at 0, -1. So that means this has to be the correct equation. Which expression is equivalent to this? So there's two ways of doing this, either algebraically, where you just subtract the numbers, or you can actually type in these two equations and then find out which other equation equals it. So for example, we type in the original equation here and we get a graph that looks like this. And now when we type in another, so we'll try the first choice, plus 6, that doesn't quite match up. So let's try the next one, plus 10. And look at that. This graph matches up perfectly with our original one. And also if we do the math, you FOIL this in, so that would be 7x cubed plus 10x. Algebraically, that also matches up. So that'd be your answer. In the xy line, a line t passes through the points 0, 9, and 1, 17. What equation defines this line? So we're given two different points, which means that we can use a table. In a table, we can just plug in our points. And this button here, it's like 4 circles with a line coming through them. This is a regression. So this pretty much takes your points, and then for whichever type of regression, whether using cubic, quadratic, or linear, or exponential, anything you want, it'll find you the equation that matches up with those points. So in this case, all our answer choices are in y equals mx plus b, which is linear regression. And we find y equals 8x plus 9, which is our answer choice D. So which equation defines this line? Y equals 8x plus 9, and that's our answer. So what is the solution to the given equation? So we can find this two ways, either algebraically or Desmos. And I prefer the Desmos ways because algebraically, we don't need to be doing all that. So in this case, we can again use regression and find out that D is equal to 30, and 30 is the solution to this given equation. And we can also find this by setting D minus 30 equal to 0, adding 30 over to each side, and we get D equals 30. Another answer would be setting d plus 30 equals to 0, so d is equal to negative 30. Both of these answers work for this question. So number 12. A store sells 2 different size containers of blueberries. The store's sales of these blueberries totaled this number plus last month. The equation this represents the situation where x is the number of smaller containers, y is the large containers. What is the price of each smaller container? So the smaller container is x, so x is 4.51. So that's how much it costs per small container. 13. The function f models the intensity of an X-ray beam and number of particles in the X-ray beam 10 millimeters below the surface of a sample of iron. What is the estimated number of particles in the X-ray beam when it's at the surface? So pretty much it's asking when t is equal to 0, how many particles are going through. So if you've taken Algebra 2, I think you learned this in, you'll know that this is an exponential function. And also, you can set this equal to 12, or x, make this x. So you might know that 500 is pretty much the y-intercept. That's when t is equal to 0, or x is equal to 0. That is your number. But if you didn't know that, you could simply plug it into Desmos, look at the graph and see, look, when t is equal to 0, so when it's 0 millimeters below the sample of iron, which is at its surface, how many particles go through? 500. And that is the correct answer. The graph of the rational function is shown where y equals f of x and x is greater than or equal to 0. Which of the following is the graph of y equals f of x plus 5 where x is greater than or equal to 0? So in this case, we don't actually get graph, so we don't know what this graph is, like what the equation is, but we can figure out that based off these transformations, this graph is going to be moved up 5 units. So when you get an equation, here, so we can model this here, so I can show you guys. 5x, or no, 5 times 2 to the x, okay? Well, we can take this, and then, if we were to apply this transformation, we would then get something that looks like this, equals g of x would actually equal f of x plus 5. And this translates our graph up 5 units. So from 0, 5 up to 0, 10, from this point down here up to this point. So essentially, our new graph that we're looking for is going to be up 5 units from the original graph. So this is down 5 units. This is also down. This is up, but not quite enough to be 5 units. So it can't be this. And look at that. This one is, because we have, it hits 10, 6, and in this one it hits 10, 1, so that's up 5 units. So that's our answer. Number 15. P equals n 19 minus c. The given equation relates to positive numbers p, n, and c. Which equation correctly expresses c in terms of p and n? In this equation, or in this case, really just solve this using algebra. I mean, just divide over the n, p over n, subtract over the 19, divide by -1, and you'll get c is equal to, and you'll get this. But if you really want to do this on Desmos, which is the much slower way, you can do this. So you could type in the original equation here, and you get 63.57. So then you can delete this equation, and then type in that. Oh, okay. So in this case, Desmos wouldn't actually really work here, because Desmos is trying to set c, or well, when you put in both numbers, when you put in both equations, it's thinking that you're like solving for something different. So it gets confused because you're setting c equal to this and then p equal to this, and Desmos won't really understand it. With regression, Desmos does understand it, so Desmos could work here, but essentially the reason it won't work with equal signs is because you're setting two different things equal to each other with the same variables, and Desmos gets very confused. So the best way would be to solve this using algebra, or if you really wanted to, you could set them equal to with a regression, and then add sliders and set them to random numbers. Set them to something other than 1, because a lot of the time you might get two answers that are the same because these constants are set equal to 1, and they might like change each other up. So to set them equal to random numbers. And then C, look at this, P is equal to 63.57, P is equal to 63.57, and since they're the same number, that means that they're the same equation, and both of these equations are correct. So and then if I was to set C to 19 plus P over N, get rid of this, you get this is negative and this is positive, which is not correct, so this one wouldn't be correct, and then these other two numbers, A and B, also aren't correct, so C or D is the only answer. The length of each edge of a box is 29 inches. Each side of the box is in the shape of a square. The box does not have a lid. What is the exterior surface area of this box? So this one's very easy. Imagine a box, pretty much. So imagine a box. I don't have a box with me. And imagine it without a top, okay? And now how many faces does this box have? It has one face here, 2, 3, and 4, and then the 5th one down here. So it has all these 5 faces. So now we need to find the surface area of these 5 faces and add them all up together. So what's the area of a square? Area of a square is just length times height, or length times width. So that each edge of a box is 29 inches. So 29 times 29 times 29, and you get 841. So that is the surface area of one face. And now we need to do this for 5 faces. So we just multiply again by 5. So we're just adding all of them up, and you get 4205. And that's our answer. Number 17. What is the sum of the solutions to the given equation? So we can do minus 5 plus 45 equals 63. So this is another cool trick on Desmos. You see that both our solutions are here and represented by both of these lines, but you can't actually click on these lines. So instead what you can do to make them clickable is just make everything, move it over to one side. So subtract this over, and you actually get clickable points. So -9 and 27. So what are the sum of the solutions? So what's -9 plus 27? And you get 18. And that's the sum of the solutions. So 18. What is the value of tan 92 pi over 3? So we can just plug that into our calculator. 2 pi over 3. And you get -1.73. So let's check our answer choices. -√3. Like that. Our first answer choice matches up perfectly. If we were to try this, that doesn't work. This doesn't work either. And this doesn't work either because it's positive, and this gives us negative. So A is the correct answer. 19. Which expression is equivalent to 42a over k plus 42ak, where k is greater than 0? So in this case, we can do a Desmos trick, where we just figure out what actually works. So, like I said, let's change the slider to something random, and set k greater than 0. So k guaranteed has to be something bigger than 0. So let's just pick 2 random numbers, something like this other than 1. And now let's try answer choices. So we're looking for an answer choice that matches 590. So this is 60. That doesn't really match our answer choice. 84 ak squared over k. That gives us 1119, which is not correct. 42a times k plus 1 over k. That's 160. That doesn't match. 42a times k squared plus 1 all over k. And look at that. That gives us our exact answer choice. So D is our correct answer. Alright, number 20. The graph of a given equation is a circle in the xy plane. The point AB lies in the circle. Which of the following is a possible value for A? Okay, so let's graph this. X plus 4 squared plus y minus 19 is equal to 121. Oh, sorry, squared. And we get a big circle. So now we're looking for a point AB that lies in the circle, but we're only looking for the value of A, so an x value. So let's set x equal to all the different answer choices and see which one lands in the circle. So negative 16 clearly doesn't. Negative 14 does, so that's a contender. 11 doesn't, and neither does 19. So negative 14 is our answer choice because that's the value of A. So then B would either be one of these two. But we're not looking for B. We're looking for what's the possible value of A. And the only answer choice that matches that is B. 21. A right rectangular prism has a height of 9 inches. The length of the prism space is x inches, which is 7 inches more than the width of the prism space. Which function gives the volume of the prism in cubic inches in terms of the length of the prism space? So right rectangular prism is just a cube, just in, well, not exactly a cube, like a cube rectangle, because not all the sides are the same, just a rectangle in a cube. They just like to use fancy language of a right rectangular prism. So we know the height is 9 inches. So if we go to a reference sheet, we know that this here is V is equal to length times width times height. So our height, as we know, is 9. So we can already eliminate A and B as our answer choice. And then we have to decide between 9x, x plus 7, and 9x, x minus 7. So the length of the prism space is x inches, okay? And that is 7 inches more than the width. So the width is the length, x, minus 7, because the width is x minus 7, because if the length is x, and the length is 7 inches more than the width has to go in the opposite direction and be 7 inches less. So in this case, D matches that instead of C. So D is our answer choice here. And now 22. The function f is defined by f of x equals a root x plus b, where a and b are constants. Graph of f of x passes to the point negative 24, and f of 24 is less than 0. Which of the following must be true? So let's graph this. F of x equals a square root x plus b. Oh, sorry. X plus b. Where a and b are constants, so we can add a slider for a and b. And it passes to the point negative 24. So let's put in a point. Negative 24 comma 0. And we'll label this guy Requise. So we have Requise over here. So let's play with our sliders and see how we can get to get on the point. So playing with our B slider moves it left and right. So we can set this equal to 24, and that will perfectly line up with our point. But now we're given one more piece of information. So we know A is wrong, because when x equals 0, y is not 24. And when f of 24, so when x is 24, the graph of y, or like the value of y, has to be less than 0. So in this case, our A value is going to be negative. So now let's check our answer choices, which is possible. F of 0, so when x is equal to 0, y is negative 24. Yeah, so when x is 0 and y is negative 24, let's see if we can get there. We can get pretty close. Look, that looks correct, right? But it's not quite right. Because when x is 0, y is negative 24.005. So that's not exactly correct. Although it might be true if you change this to like 0.0001 or something, and maybe that gets you closer. But that's not what it's asking for. It's asking for which is like guaranteed to be true, like what's the easiest one, what's like always right. And because of this, College Board will always have to ask you which one is completely right no matter what. Like, it cannot be a debate. Like, the answer to the question cannot be a debate for a College Board, okay? Because if they put a question on the SAT that could have like 2 different answers, essentially, if answering one of the 2 correctly, if you like answer it, that's also true, but College Board marks it wrong, that messes with like your actual like academic performance, and College Board can't really count that. So all their questions have to have only one true answer. Otherwise, like your score is going to be invalidated because they messed up on their test. They put an answer choice that could have been something when in reality it wasn't the answer, even though it could have been as well. So because of that, every single SAT question or every single AP test question, it's all like super thorough. It's all checked through all the answer choices. It can never be this. So which one is always true? And in this case, B is actually greater than A. So A is less than B. So D is our correct answer. Because this, looking clearly at our graph, with any point here, with the A being less than 0, makes A less than B. So in this case, D is the correct answer. And that's everything for Module 1. So let's move on to Module 2. Alright. Number 1. A right triangle has legs with lengths of 11 centimeters and 9 centimeters. What is the length of this triangle's hypotenuse? So this is just Pythagorean theorem. 11 squared plus 9 squared, equals 202. So equals 202 squared, so the square root of that. And if we look at our answer choices, square root 202 is our correct answer choice. Because a squared plus b squared equals c squared. And if we get this at 202, we have to square root this to find c, and that is our answer. For the linear function h, the graph of h of x and the xy plane passes the points, which equation defines h? So this is going to be the same thing as we did earlier. We're just going to set up a table, 721, 925, and then since it says linear, we're just going to put linear regression. Y equals 2x plus 7, and that's our answer. Simple as that. Okay, number 3. The company that produces socks wants to estimate the socks that are defective in a typical week. Random sample of 310 socks. Based on the sample, it's estimated that 12% of all socks produced by the company are defective, with a margin of error of 3.62%. Based on the model and margin of error, which of the following is the most appropriate about all socks? So margin of error means that the actual value that they found, so the estimated 12% of socks that are defective, it could be plus or minus the margin of error. So in this case, the number of socks that's produced is actually anywhere from 12 minus 3.26%, so like 8.38%, or it could be up to 15.62% because plus or minus 12%. So let's look at our answer choices. A, 3.62% of socks are defective. That's not true. That's actually a margin of error. 12% of the socks are defective. That's true, but we have a margin of error, so that's not true. And it's plausible that more than 15.62% of the socks are defective is not true, because the margin of error is 3.62%. So that means plus or minus. And it is plausible that between this number and this number of the socks are defective, and that is correct. Because anywhere between that is where the margin of error is. So that is our plausible answer choice. So number 4. A truck can haul a maximum weight of 5,630 pounds. The truck's going to haul a 190-pound piece of equipment and several crates. These crates weigh 25 pounds each, and others weigh 62 pounds each. Which inequality represents this? 25 is x, and 62 pounds is y. Okay, so in this case, the number of crates, x's and y's, has to be less than the maximum weight. So in this case, B is automatically ruled out, and so is D. And in this case, let's look. So 25-pound crates is x, and 62-pound crates is y. So A is the only possible answer choice. And also, now you might be wondering, hey, but I thought the maximum weight was 5,630 pounds, not 5,440. But you might be forgetting that he also has to haul a 190-pound piece of equipment. So if we do this minus the piece of equipment, we get 5,440. So the crates have to be less than or equal to the total weight. Number 5, what is the solution xy to the given system of equations? So this is the easiest possible problem that you can solve using Desmos. Y minus 9x is equal to 13. 5x is equal to 2y. And then literally just look at where they intersect. -2, -5, and that's your answer choice. This is the easiest possible question that you'll have on Desmos. It's literally just what is the solution, just find where they intersect. What is the range of the 7 scores shown? Okay, so Desmos unfortunately doesn't have a range function, at least not that I've found before. Unlike they have like the median function and the mean, but they don't have a range. So what does range mean? Range is the difference between the highest number and the lowest number in a data set. So in this case, our highest number is 52, and our lowest is 23. So what's the difference? 29. So the range is 29. All right. Number 7. 2 customers purchased the same kind of bread and eggs at a store. The first customer paid $12.45 for 1 loaf of bread and 2 dozen eggs. And the second customer paid $19.42 for 4 loaves of bread and 1 dozen eggs. What is the cost in dollars of 1 dozen eggs? So, in this case, we're actually going to set up a system of equations. So, we're going to set up so that it looks something like this. So pretty much what this is saying is that anything inside this bracket here is actually pretty much like anything equal to what's in this bracket, if that makes any sense. So we're setting up a system of equations. So in this case, we'll set loaves of bread equal to A, just for simplicity, and then eggs equal to B. Okay, so the first one was 1 loaf of bread, so 1A, plus 2B is 12.45. And so that's our first system of equations. So now the second one is where we have to separate them using a comma, and then after that we can put in our second system of equations. So in this case, the second customer paid $19.45 for 4 loaves of bread, so 4A, plus 1B, which is just because it's 1 dozen eggs, and set that equal to 19.45. 42. And in this case, it finds out that, hey, 1 loaf of bread is $3.77, and then 1 dozen eggs is $4.34. So what is the cost in dollars of 1 dozen eggs? So we set that equal to B. So that is 4.34, which is D. Number 8, y equals 18. All right, so if the given system of equations are graphs in the xy plane, how many points do the graphs intersect? Okay, so it's just finding intersection. So let's put this into Desmos. So minus 18 squared plus 15. Okay, and then we'll zoom out. So these actually never intersect, and because these points just never touch. You can also find this. So y is equal to 18. So that means that the first line is just a straight across line at 18 on the xy plane. And then in the second equation, this is a parabola. And the plus 15 here in this case represents that the highest at the vertex will be at 18, 15, which is true in this case. So this is a vertex form parabola. And 15 shows that it's up 15. So, and since 18 is actually greater than 15, shocker, right? These points are never going to touch, or these 2 lines are never going to touch, because the y is greater than the parabola. So in this case, 0 is our answer. Number 9. Solution to the given system of equations is x, y. What is the greatest possible value of x? Okay, so this one's also really easy. Let's put this into Desmos. So y equals x squared 16x plus 63. And okay, so in this case, the line intersects twice into this graph. So a solution is xy. So both of these work as solutions to this equation. But we're looking for what's the greatest possible value of x. that is also a solution. So in this case, we are choosing between -9 and -6, and -6 is greater than -9. So -6 is our answer choice, because it's the greatest possible x value that is a solution to the given equations. Number 10, in the xy plane, line P has a slope of -5/3 and an x-intercept of -6. What is the y-coordinate of the y-intercept of line P? So we know the line P, so we'll define it as f of x, has a slope of -5/3 x, and it also has an x-intercept of -6, 0. So we'll label this guy the same thing, and we'll kind of just like add or subtract numbers in this case until we find a number that kind of works. And in this case, look at that, -10. Does that go through the point? Yes, it does. So in this case, this actually passes through the point, and so that means that -10 is the y-coordinate of the y-intercept of the line. Because graphing this line, it passes through the point, the x-intercept, so it satisfies this equation. And what's the y-intercept? -10. So -10 is our answer. In this case, we're just doing some guessing and checking to find our answer. 11. How many solutions does the equation this have? Okay, so we plug this into Desmos. -3 x plus 12. And look at that. We only have one line. But the one thing to be careful with on Desmos is this could either mean infinitely many solutions, or it could mean one solution. So let's check. So we're gonna take both sides of these equal and just set them to y. Set them equal to y. So y is equal to 12 times x minus 3. So that's our first, and then y is equal to -3 x plus 12, and we'll get rid of this, and then we'll see. And their intersection is at 0 and -3, which means that there's only one solution. So exactly one. So number 12, Kaylani used fabric measuring 5 yards to make each suit for a men's choir. The relationship is modeled by y minus 5x equals 6, where y is the total length of fabric that she purchased in yards. What is the best interpretation of 6 in this context? Okay, so this is saying that the total length of fabric that she purchased was y, and then each suit, which is x, takes 5 yards of fabric. So let's see. Kaylani made 6 suits. That doesn't make sense because x is how many suits she made, and 5 goes here, not 6. So that one is not correct. Kaylani purchased a total of 6 yards of fabric. That's not possible either, because if each suit takes 5 yards, then you can't have you can't make 1.2 of a suit, or 0.2 of a suit, which is only using 1 yard, so that one doesn't really make sense. She used a total of 6 yards of fabric to make the suits. This also doesn't make sense because it's the same thing. You can't have 0.2 of a suit. If you're using 5 yards of fabric per suit, you can't have 0.2 of a suit, so that doesn't make any sense. And Kaylani purchased 6 yards more fabric than she used to make the suits. And that actually makes sense, because in the equation y equals 5x plus 6, x is how many suits she made, y is how much fabric she bought, and if 6 is your intercept, that's how much fabric is left over. So in this case, D is our correct answer. 13. Which quadratic equation has no real solutions? So this is another guess and check. Or we'll just graph it actually in Desmos. So this has real solutions, so it's not this one. Plus 49 minus 14. This also has a real solution. This so far doesn't have a real solution. And this one does. So all of these all have solutions. And in this case, this one doesn't have a solution because it doesn't touch the x-axis ever. So in this case, our real solutions would be imaginary numbers. And since it never touches the x-axis, it has no real solutions. So D is our correct answer. Alright, 14. The function f is defined by the given equation. The equation can be rewritten as f of x equals that, where p is a constant. Which of the following is closer to the value of p? So we're looking for what's closest to the value of p, not what is the value of p. So we are going to do, again, you guessed it, Desmos and guess and check. So we have our first line. So this is the original equation. And now the next one can be, call it g of x, just to not make things confusing. 1 plus p over 100 to the x. Okay, now we'll add a slider for p. Okay, so we'll use 16 as our first member. And that actually works out quite well. That looks really solid. But let's try the other numbers, see if we get anything closer. P is equal to 21. That looks significantly less close than 16. So it's probably not 21. We can try 46, and that's way farther than 16. And 96 is the exact same thing. So in this case, A is the closest value of P. Okay, 15. In the given system of equations, P is a constant. If the system has no solution, what is the value of P? Okay. So we're going to just put this into Desmos. And we'll replace R with X and P with Y. And we'll add a slider for W. So 7x minus 5y is equal to 5w plus 11. Okay, and now we have to, with the slider of W, we'll find when it has no solution, so pretty much when these two lines are parallel. So let's find out when these lines are parallel. So at 5 it looks pretty parallel. 5.2 definitely not. 5.1 definitely not. Here's the point of intersection. 5 works well. 4.9 definitely not. So 5. So if the given solution, oh sorry, in this case we're looking for P, not W. That's my mistake actually. So we'll replace W with Y. So let's try this problem again. We'll replace W with Y and leave P, because P is what we're solving for. So 6 plus 7R equals PW. R is X, W is Y. 7X minus 5Y is equal to 5Y plus 11. Add a slider for P. Alright, let's try the same thing. And look at that. 10 seems to work out quite well. It's 9.9, they touch here. Right now they touch farther down here, yeah. So at 10 they just never touch, it looks. And we'll zoom out and see if there's any sneaky numbers. Nope, nothing. So P is equal to 10. And in this case, you can also look at this algebraically. If you add, in the second equation, if you add over 5W, you get 10W. And so 6 plus 7R is equal to PW. And then 7R is equal to 10W plus 11. When you cancel out the 7R's from both equations, you get 6 is equal to 11 when P is equal to 10, because it's 10W. So PW is then just 10W. And 6 equals 11 is not true. So P has to be 10. So that's another way of looking at it algebraically. But Desmos is significantly easier. So number 16. This graph is shown where B and C are constants. What is the value of B times C? Okay, so let's just create this graph. So we use a table and we see like the dots here. These dots represent points on the graph. So right here. So we can see, okay, -2 and -6. We can do -1 and -8 and 0, -6. Then we'll add a regression to solve the equation for us. And we'll make this quadratic. And look at that. We have y equals 2x squared, which is correct, plus 4x, so bx, plus c. Where b and c are constants, what is the value of bc? So if we just type in this case, b is 4, because 4 matches up with bx, plus c, so c is -6. So if we multiply these two, we get -24. That's our answer. Alright, number 17. The graph of the linear function is shown if c and d are positive constants. What could define f? Okay, so right now what we're seeing is f of x plus 19. So it's the original equation up 19 units. So that's the graph. So that means that in this case, the original graph is going to be, like the y-intercept for that graph is going to be below the x-axis. So it's going to be in the negatives. Because if it's translated up 19 units, and it's now at 3 in this new graph, that means that the original one has to be below x. So in this case, we can know that our d, which correlates to our y-intercept, has to be negative. So we can rule out b and c already. And we have no other transformations, which means that we can assume that the slope is going to be the same. So in this case, we're having a negative slope because it's going downwards. So we can cancel out c, and we can see with full confidence that a is the correct answer choice. Because d is going to be negative, which is our y-intercept, and then our slope is also going to be negative. So that we can say with confidence, a is our answer. Alright, 18. In the figure shown AB, so this side here, is root 34. AC is 3, CE is 21, and we need to find the area of ADE. So we're going to use a regression, like proportion regression in this case. So we know that AC is 3 units, okay? So 3 over, and CE we know is 21 units, so 3 over 21, we can do the regression, is, and we know AB is root 34, so it's root 34 over T. So pretty much this is saying AC over CE is as to AB to BD, kind of, if that makes any sense. So in this case, we're finding out that the length of BD is 40.81666. So now we need to find the area of triangle ADE. So now you might have recognized if we have the length of one side and the length of the hypotenuse, we just need to find the length of the height. So, and that is Pythagorean theorem. But we have to be careful here. We know that AE is actually AC plus CE. So it's 24 squared plus B squared equals C squared. In this case, our C is AB plus BD. So 34. So we'll do square root 34 plus 40.81666. And we will, oops, sorry. Where's the square root? Yeah, square root 34 plus 40.81666. Or in this case, if you want, you could write T instead of the 40. That gives you actually the same thing because it knows that T in this case, you set that T equal to this number. So it'll know that T is that. And then squared. And we don't want to do an equal sign because it won't actually solve anything for us. So we'll just do regression. And we find that B is, in this case we can tell Desmos that B has to be greater than 0. Or not. Okay, well let's find a different way since regression didn't work that way. So you know that our base is 24 squared. So 24 squared is what? 576. And then we know our C, which is, so what, root 34? Square root 34 plus T. And we can square that. And we get 2,176. So that's our C. Now we're trying to find our B. So we need to isolate our B's, because if it's A squared plus B squared equals C squared, and we have our A and we have our C, we need to isolate our B by subtracting over our A. So in this case, we can take 2176 minus 576, and we get 1600. So now, what is the square root of 1600? That is 40. Okay, so now we have our height and we have our base. And what's the formula for the area of a triangle? It's 1/2 base times height. So if we have our base as 24 times base of 24 times our height, which we know is 40 now, we get 480. Awesome. Number 19. The result of increasing the quantity x by 400% is 60. What is the value of x? So we know C and D are automatically wrong just right off the bat. And this is actually a very common trick question on the SAT. It's not asking what is 400% of 60, as in like what number of x when increased by 400% is 60. It's asking when you're increasing x by an additional 400%. So when you're adding on 400% of x to the original x, that gets you 60. So what's the value of x? So in this case, we can do x plus 400% of x. We're actually to 60, and we can't do x because x is defined as variable, so we have to do constant. And we get 12 as our answer. So essentially, this is saying that a number. So it's solving for like the constant. So constant x1 plus 400% of x1 is 60. So what is x1? And in this case, it's giving us our answer of 12. Because when you do 12, what's 400% of 12? 48. So what's 48 plus 12? 60. And in that case, that's our correct answer. Number 20. In the xy plane, a circle has center C with coordinates hk. Points A and B lie on the circle. Point A has coordinates h1 plus k plus root 1 of 2, and ACB is a right angle. What is the length of AB? So let's make a, to help us visualize this, let's just draw a circle. xy is equal to, call it 10 squared. So we have our circle here, okay? And so a circle has a center of C. So C comes 0, 0. We'll label this C. Which has coordinates hk. Points A and B lie on the circle. Point A has coordinates at this, and ACB is a right angle. So that means it's going to form a right triangle. So we can label A somewhere on the point, and in this case, we'll make it simple. We'll call it 0, 10 at the top, and then B we'll set equal to, we'll draw a point of 10, 0 on it. And then we'll label these points. Okay, so this is essentially what this is going to look like somewhat. Maybe the points are somewhere else, but this is just to help us visualize this graph, this circle here. So what is the length of AB? So it's looking for this length here. Okay, so we have the coordinates of C and A. So now we need to find the distance between them, because we don't actually know that it's 10. In this case, we're just drawing 10 as a visual example to help us realize, help us understand what it's going to look like, help us visualize it. So, I know Desmos has a distance, but I don't want to use it with variables. So in this case, we'll use the original distance formula, which is square root of x1 plus x2 squared minus y1 plus y2 squared. Actually, hold on, let me check that. No, I'm wrong. x2 minus x1. Yeah, I knew the plus goes in the middle. y2 minus y1. I always get confused with this. So in this case, this is pretty much going to be our distance formula. So let's plug in our constants. And when you get a bunch of weird constants like h, k, and stuff like that, chances are they're going to cancel out when you plug them into the right formula. So let's plug it in. Square root of x2, which we'll call C, x2. So we'll do h minus x plus 1, or h plus 1. Okay, because h minus h plus 1, because that's our x coordinate of both. Then we will do plus y2, which is, we started with circle C, or point C, so we have to continue with point C, minus k plus square root 1 and 2. We can close this parentheses, both And so now we have this. Okay, so what's h minus h? H minus h is just 0, so we can get rid of this. So we get 1. Plus, and then what's k minus k? 0 again. So we can cancel this out. And we get this. So this is our length, if I'm not mistaken. We forgot the squared. Squared. So this is going to be our length between A and C. So now, if we know that ACB is a right angle, which is stated right here, we have to find the length of AB. So in this case, AB is going to be the hypotenuse, and we have AC. So it's just going to be Pythagorean theorem again. So we can copy this number, 10.14889. We can round it. It's most likely close enough. Squared equals C squared. Actually, we'll take this number, and then we'll find the square root of this. So in this case, it's square root of 509.99. So we can just round that to 206. And in this case, look at that. What's the length of AB? Root 206, which is the answer that we got right here. So that's the correct answer. Number 21. Alright, we'll skip number 21 since it's longer and move on to 22. The scatter plot shows a relationship between x and y for dataset E. A line of best fit is shown. Dataset F is created by multiplying the y-coordinate of each data point by 3.9. Which of the following can be an equation of a line of best fit for dataset F? Okay, so we have our y-intercept at about, what is this, 13-ish? If this is 15, yeah, like 12-ish. So if we're multiplying each y-coordinate of this value, we can't start with the same y-intercept, because if we're multiplying by 3.9, then the y-intercept is also going to be multiplied by 3.9. So C and D are automatically wrong. And now, when we multiply each number by 3.9, our slope is also going to change. Because if you visualize this, if you have a point right here, and then you multiply by 3.9, that gets you up here. But if you have a point that starts here, and you multiply by 3.9, it's going to end up here. So for example, 10 times 3.9 is 39. And then like something like 15 times 3.9, that gets you 58. And I don't know about you, but 58.5 minus 38 is not the same thing as 15 minus 10. Sorry, 39. Is not the same thing as 15 minus 10. So the difference between these 2 points here, when multiplied by 3.9, is 19.5. And then in the original, it's only a distance of 5. So our slope is also going to have to be steeper to catch up with the points as they are being multiplied. So in this case, A would be our correct answer, because although B is the same y-intercept, the correct y-coordinate, its slope is not also being multiplied by 3.9. So now 21. For an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface of the product of the is the product of the electric field strength in the area of the surface. Okay. A lot of the time in the SAT, you'll read some questions that make absolutely no sense, and this is one of them. So when they make no sense, or when it's talking about like physics, like something about like work, if it's talking about like electromagnetism, it'll always give you the equation in like the actual text. So in this case, for an electric field passing through a flat surface perpendicular to it, so here's a flat surface, electric field is passing through it, here. The electric flux of the electric field is the product, so we're trying to find something, most likely we're trying to find electric flux, is the product of the electric field strength and the area of the surface. Okay, so we know that electric flux EC is equal to electric field strength, so EFS times area, so times A. A certain flat surface consists of two adjacent squares, so two squares right next to each other, where the side length in meters of the larger square is 3 times the side length of the smaller square. An electric field with strength of 49 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. So we know that it's going to be applied to the first equation because it's talking about being perpendicular or something. So, and we know that our electric field strength is 29 volts. Okay. If the total electric flux passing through the surface is 4,640 volts per meter, what is the electric flux of the electric field through the larger square? Okay, so we're given the electric flux of everything, and then we need to find what it is through the larger square. So, in this case, we have two flat squares, where one is 3x, the other one. Okay, so we can draw this out. So pretty much imagine a square. Yeah, something like this. Imagine a square. So this is 3 times of the small square. So we have 2 squares here. Okay. So one of them is 3. So this is the small square is going to be x and x, and then the larger square is going to be 3x and 3x. So we have 3x times 3x. So that eventually gives us, that's going to give us 9x, plus x times x, which is just x, and that is going to give us 10x, okay? So our total surface area, or total area, is going to be 10x. And so we know that the total electric flux is 4,640 volts per meter. So if we remember, electric flux is equal to the electric field strength, so EFS, times area. So EC is equal to EFS times area. So we know that the electric flux is 4,640, and the strength is 29, and we have to multiply that by 10x, because that was our area. So in this case, we can have Desmos solve for x for us, just with using regression. And we get x1 is equal to 16. So we know that each side length is 16 for each square. Okay, and now we're trying to find what is the electric flux of the field through the larger square. So if we remember, the larger square was 9x. So what's 9 times 16? 144. And now how do we find electric flux? Electric flux is 144 times 29. And that gives us 4,176, and that is our electric flux through the larger square. And that should be everything. So let's submit and see what we get. X is over, stand by. Perfect, so let's go view our score. Alright guys, and as you see, this is the practice test we just took, December 10th, and we scored a perfect 1,000. Which is a maximum score on the math section. So an 800 in math. As you can see, every single question is correct. 44 right, 0 wrong. So guys, that's my SAT walkthrough for practice test number 5. Thank you guys so much for watching. Don't forget to like, subscribe, drop a comment, follow, do all that jazz. And hopefully this helped you a lot. Hopefully you learned some cool Desmos tricks, some regression, some systems of equations with regression, some tables with regression, and just how to solve most of these problems, just figuring them out, you know. So hopefully this helped you guys. I'm going to be posting more of these soon, hopefully finishing this entire series before the January SAT, so you guys have the most amount of time to study. And that's it. So thank you guys so much for watching, and have a great rest of your day. Peace out.